Welcome to Sleepy Stories. This space is gentle on purpose. You can learn at an easy pace, and if rest arrives partway through, that is perfectly fine. Knowledge does not need to be rushed. It can move as slowly as starlight and still arrive. If you enjoy these quiet journeys, a simple like or subscription helps keep them going. It ensures that calm explanations keep meeting curious minds. Far out in the Pacific, the night settles over an ancient volcano. On its high slopes, where the air is thin and still, two white domes remain awake. Inside them are the instruments of Atlas, the asteroid terrestrial impact last alert system, designed to notice motion in the sky that might one day matter to Earth. The purpose is practical. Watch everything, all the time, with steady attention. The practice is patient. Image, compare, verify, repeat. Each night follows a rhythm. A patch of sky is photographed and then photographed again. Software subtracts one image from the next, searching for anything that moves against the quiet lattice of stars. Most of the time the movement is familiar. A known asteroid, the gentle arc of a planet, the trace of a satellite sliding through the field. What remains after those are removed becomes a list of candidates, ordinary and unhurried, each waiting its turn for review. In this routine lies the essence of discovery. The universe rarely announces itself with spectacle. It reveals itself through consistency, the same instruments, the same methods, the same care, until a small difference appears. The difference is usually nothing. Sometimes it is everything. The work is to tell those two apart without noise, without haste. On an ordinary night, a point of light appeared that behaved differently. It was not dramatic, not bright, not unusual to the eye, but the numbers were precise, and the numbers did not match expectation. The candidate's motion, measured over a short sequence of images, suggested a speed and direction that did not fit the slow geometries of objects bound to our sun. The software marked the point and wrote a line into the log. The operators noted the time and continued. That is how attention scales, by trusting process first, interpretation later. Hours pass like this in observatories everywhere. Instruments hum, screens glow, data accumulates. The same actions repeat because repetition is how uncertainty becomes understanding. In the morning, when the night's files are reviewed, the same point of light is there again, shifted farther than a bound object would travel in that span. The algorithms are cautious. The people are cautious. Caution is not doubt. It is the form that clarity takes before it is earned. The domes turn to rest in daylight. The mountain returns to silence. Scientists at other facilities read the coordinate alert that Atlas has posted to the shared network. A few classrooms far away discuss how telescopes see at night. A handful of amateurs point their instruments to the same place out of simple curiosity. Nothing about this looks remarkable yet, and that is exactly right. Most of science looks like this. Careful, ordinary, methodical. Still, the numbers have already begun to trace a shape. They describe a visitor whose path through our neighborhood is too fast for a closed orbit, a traveler likely arriving from beyond the long, dark shell of icy bodies that surrounds our system. The story is not written. It is accumulated. It will be built from more images, more timestamps, more checks, and the quiet agreement of many eyes looking together. For now, it is only a faint record of motion where little motion was expected. That is enough. It is how many real stories in astronomy begin, with a small deviation from routine, preserved by discipline. If you picture the mountain tonight, imagine a clean horizon, cool air, and instruments turning with steady confidence. Above them, the sky holds more than any single image can show. Somewhere within that expanse, a point of light has started a journey through our awareness, and the act of noticing has already changed what we know. On the summit of Mauna Loa, the night unfolds with mechanical grace. Inside the twin Atlas domes, cameras take rapid exposures of the sky, one every 30 seconds, each recording thousands of stars. The software compares every new image with the one taken just before it. Any pixel that shifts becomes a possible sign of motion. Most changes are meaningless. A cosmic ray striking the detector, the blink of an airplane light, a faint glimmer from a passing satellite. But every anomaly is logged. The instruments make no assumptions. They simply watch. The operators in the control room know this rhythm by heart. It is the heartbeat of observation, a repetition so steady that thought itself grows quiet. The screens show fields of stars, black and white grids that appear motionless to human eyes. Only the computer sees the subtle dance hidden within. Its algorithms sort the sky into three categories: fixed, known, and uncertain. It is the uncertain that matters most. Shortly after midnight, one of those uncertain points appears again, faint, steady, moving just fast enough to be unusual. The software flags it automatically. In the long list of nightly detections, it earns a simple mark. Object requires confirmation. It is routine, a common classification that means watch again. But later, when the night's data are reviewed, that line will stand out. The next night, under the same still air and cold stars, the same coordinates are observed again. The point has shifted farther than expected. The analysts double-check the timestamps, suspecting a calibration error, but the timing is exact. Atmospheric distortion is ruled out. The signal is clean. Whatever this object is, it is not moving as things normally do. At dawn, the mountain glows pink with the first light of day. The domes begin to close, sealing in the faint scent of metal and ozone. Inside, the computers continue to process the night's data. In one of the folders lies a series of images that will later become famous. For now, they are only numbers, a small collection of coordinates describing a streak of light that should not exist. The staff sign off and leave the control room in silence. Outside, the wind moves gently across volcanic rock, carrying the warmth of the rising sun. No one yet realizes that the night's discovery is not local, not even solar. It belongs to the larger sea of interstellar space. The telescopes, still warm from the night's work, have touched something ancient, a visitor crossing the border between stars. In most discoveries, the human moment comes last. Long after the data are recorded, someone looks closer and notices the pattern. That will happen here too. A quiet realization during an ordinary review, perhaps accompanied by a slow intake of breath. The object has no name yet, no meaning beyond its coordinates, but meaning, like motion, begins in small increments. By the time the mountain enters its next night of darkness, the world below will still have no idea that a fragment of another system has passed through its field of view. The discovery exists only as a line of code and a silent entry in a database. Yet from such small signals, entire stories begin, not in triumph, but in patience. When the morning analysis began, the night's data looked almost identical to hundreds of runs before it. But in one sequence, buried deep in the log, a faint line of motion refused to align with known orbital models. The coordinates placed it near the constellation Hercules, a region often visited by near-Earth objects. At first, analysts suspected a reflection from a passing satellite or the faint streak of a cosmic ray. Yet when they compared multiple images, the same point reappeared, consistent in position, brightness, and speed. The algorithms recalculated its movement. The numbers suggested an object traveling far faster than any asteroid belonging to the Sun's family. Its path, instead of forming an ellipse, curved gently outward. The trajectory implied escape, not return. By mid-morning, verification requests were already moving across international networks. Observatories in Chile, South Africa, and Spain turned their instruments toward the same coordinates. One after another they confirmed it. The point was real, and it was moving far too quickly to be bound by solar gravity. That realization created a rare stillness in the control room. Astronomers see countless motions every night, but this one disobeyed the quiet geometry of the planets. If its course held true, it had entered our solar system from outside, drawn slightly by the sun's pull, and would soon continue into the dark again. In a universe full of motion, this was motion of another kind, a visitor rather than a resident. The first press of awe did not come from spectacle but from arithmetic. Numbers alone told the story. The analysts plotted the object's path through time, a smooth curve sweeping across the inner system. They knew at once how brief the encounter would be. In only a few months, it would pass the orbit of Jupiter and vanish back into interstellar space. There would be no second chance to see it. Such knowledge always brings a mix of exhilaration and restraint. The excitement of discovery collides with the discipline of proof. They would need to check everything: calibration, timing, atmosphere, detector sensitivity. Each potential error was investigated and dismissed. The evidence grew firmer with each test. Before the day ended, the data had been sent to the Minor Planet Center, the clearinghouse that collects every credible observation of moving bodies in the sky. From there, the information spread quickly through the professional community. Screens across the world lit up with the same figures: right ascension, declination, magnitude, velocity. On every one of them, the numbers whispered the same improbable truth: this object came from somewhere else entirely. Outside the observatory, clouds drifted along the horizon, their slow movement a mirror of the calculations within. Nature often repeats itself across scales: the shape of wind, the sweep of stars. But every so often, a path breaks pattern and invites attention. This was one of those paths. As the sun set again over the Pacific, the Atlas domes reopened. Their rotation resumed as if nothing unusual had happened. Yet everyone who worked there knew that the night ahead would not be ordinary. Somewhere out there, beyond the familiar orbits, a line of light was tracing its way through history, not a visitor with intent, but a piece of elsewhere passing silently through our sky. In astronomy, names are more than labels. They are coordinates of memory. Every discovery must be entered into the great archive that keeps the sky organized, so that anyone, anywhere, can find what someone once found. When the Atlas team submitted its formal report, the object received a provisional designation, a string of letters and numbers marking time, location, and sequence. But as confirmation arrived from observatories across the world, the designation was revised into something rarer and simpler: 3I Atlas. The code carried meaning in each part. The numeral 3 marked it as the third interstellar object ever confirmed. The letter I stood for interstellar, and the final word Atlas honored the system that had noticed it first: 2 quiet telescopes on a volcano above the clouds. The name turned the unknown into something holdable, something that could be spoken aloud. In that act of naming, the object entered the record of human observation, becoming part of a lineage that began centuries earlier with the first catalogued comets. The announcement, published through the International Astronomical Union, was brief and factual. No poetic language, no speculation, only position, brightness, and motion. Yet behind those details, an unspoken awareness spread among those who study the sky. Humanity had once again caught sight of material born around another star. For the third time in recorded history, something from outside the solar family had crossed our orbit. Across time zones, astronomers paused their own work to read the notice. Some printed it and pinned it near their desks, a reminder of why they measure. Others simply looked up that night, not to see the object, it was still far too faint, but to appreciate that the sky above them was connected to a journey millions of years old. Naming 3I Atlas also meant responsibility. To name is to begin study. Every telescope that could track its faint light was now tasked with collecting data before it disappeared. Within hours of its confirmation, requests for observation time poured into scheduling systems. Some were approved, others denied, each competing for the same small window of visibility. The visitor would remain bright enough for only a few months. At the Atlas facility itself, the mood was quiet, not triumphant. Those who had worked through the nights knew how much luck accompanies precision. Discovery in astronomy is often a matter of being pointed in the right direction at the right time, with instruments sensitive enough to notice what the sky had always been doing. The operators watched as the names spread across databases, news feeds, and research logs, aware that most of the world would never hear it. The significance was not fame, it was participation in the long continuity of watching. When the first public release appeared, a short paragraph described it simply: Object 3I Atlas detected, hyperbolic trajectory confirmed, likely interstellar in origin. That was all. Yet those 3 sentences held everything essential. Arrival, evidence, and departure, already implied. Outside, night returned to the mountain. The domes turned eastward once more. The air thinned, the stars sharpened. Somewhere in that glittering expanse, Three-Eye Atlas was moving, unaware that it had been named, unaware that it had joined our vocabulary of wonder. Names, after all, are human tools. The universe carries on without them, but for the watchers below, a single name was enough to turn motion into meaning. Once a new object is confirmed, the first question is always the same. Where is it going? In astronomy, every motion carries its own story, and the mathematics that trace those paths become a kind of biography written in numbers. For Three-Eye Atlas, those numbers were startling from the start. Its velocity was far higher than any asteroid native to the Sun's system, fast enough to escape even the strongest gravitational wells. The data spoke clearly. This visitor was not bound to us. It was merely passing through. At the minor planet center, clusters of analysts began feeding the coordinates into orbital models. The software translated dots of light into motion, motion into probability, and probability into trajectory. The resulting graph showed a curve, unlike the closed ellipses of planets or comets. It was hyperbolic, an open path that would never circle back. The object would enter, curve slightly under the sun's influence, and then slip away into the dark again, never to return. When the model was shared across observatories, every recalculation confirmed the same truth. The speed was too high for capture. The sun could bend its path but not hold it. To anyone who reads the sky professionally, that single detail carries deep meaning. It transforms the observation from local to cosmic. What they were seeing had begun elsewhere, around another star, perhaps hundreds of light years away, and after its brief encounter here, it would continue on its endless drift. In the control rooms, the reaction was subdued but unmistakable. Charts updated, graphs smoothed out, uncertainties shrank. A few quiet exclamations broke the usual calm, followed by the familiar silence of verification. Numbers like these are rare, and those who work with them feel their weight. The data meant that Three-Eye Atlas was only the third confirmed interstellar object ever observed by humans. The odds of detecting it at all were almost unimaginable. Astronomers plotted its path through the inner system. It would sweep between the orbits of Mars and Earth before veering outward again toward the edge of the solar frontier. By the time it passed Jupiter's distance, it would be too faint for any telescope to follow. Every observation window was counted in days, not months. The calculations also revealed when the object had first entered our neighborhood. Tracing the line backward through time showed that it had crossed the boundary of the outer solar system months before anyone noticed. For all that time, it had been invisible, silent, untouched by awareness, a fragment of somewhere else, moving without purpose but with exquisite precision. As the graphs accumulated, a sense of scale returned to the room. What they were studying was not merely a comet or asteroid, but a message written by the galaxy itself. Its trajectory mapped the gravitational conversation between stars, how worlds shed material that drifts across the void, carrying chemical stories of their origins. Three-Eye Atlas was one such story, now legible for a moment before it continued on its way. That night, when the telescopes resumed their work, the observers looked at the familiar screens with new attention. Somewhere within the thousands of dots they measured each hour, one was not of this place. They were recording the trace of a traveler whose journey began long before human thought had words for the stars. The first calculations had revealed the truth of motion. The next task would be to uncover the nature of what was moving. Once the orbit of Three-Eye Atlas was secure, attention turned to understanding its substance. What was this thing made of? Rock, ice, dust, or something stranger still? In astronomy, answers begin as faint variations in light. Across the world, observatories reoriented their instruments toward the newly announced visitor. The Keck telescopes in Hawaii, the Very Large Telescope in Chile, and the Subaru Observatory on Mauna Kea all joined the effort. Every photon mattered, every reflection carried a fragment of information. The challenge was time. The object was moving quickly, its brightness rising as it approached the sun, but its window of visibility would close almost as soon as it opened. Researchers coordinated observation schedules with unusual precision. Some worked through the night, others woke before dawn to catch their allotted hour. The shared goal was to build a continuous picture before the traveler faded into distance again. The first results came in the form of light curves, graphs showing subtle changes in brightness over time. Those small oscillations revealed rotation. 3i Atlas was spinning, not fast but steadily, completing a turn every few hours. From the shape of its light pattern, astronomers inferred an irregular form, perhaps slightly elongated. It was not a perfect sphere, nor a simple fragment of stone. Its surface reflected sunlight unevenly, as though coated with volatile material that shifted and released gas as it warmed. Spectroscopic data followed next. By separating the light into its component colors, scientists could read the chemical traces hidden within. The spectra showed narrow lines of carbon dioxide and faint evidence of cyanide compounds, a chemical signature typical of comets. But one element stood out: an unusually high ratio of carbon dioxide to water vapor. In our solar system, most comets are rich in frozen water. This one was not. Its chemistry suggested formation in an environment far colder than anything around the Sun, perhaps at the frozen edge of another star's planetary disk. With that evidence, a consensus began to form. 3i Atlas was not a rocky asteroid like the mysterious Oumuamua, but an active comet. It was venting gas as it approached the Sun, forming a faint halo, a coma, invisible to the naked eye but measurable through careful imaging. In a sense, it was breathing for the first time in eons, sunlight waking frozen ices that had slept since before human civilization began. Each observation strengthened the same conclusion. This was a natural body, a wanderer shaped by physical forces alone, no mystery beyond physics, no artifact of intention. Yet the beauty of it lay precisely there, in the reminder that ordinary matter, set in motion under simple laws, can create something extraordinary simply by existing. Astronomers continued their measurements late into the night, adjusting exposures, recalibrating instruments, logging temperatures and air stability. The observatories became islands of quiet concentration. Beyond the domes, the world went about its usual rhythms: waves against lava rock, wind through sparse vegetation, city lights faintly visible far below. But inside, every second of exposure felt like dialogue with something immeasurably old. The data flowed across networks to universities, agencies, and independent researchers. Even with the best instruments, each telescope could only glimpse part of the picture. Together, they formed a mosaic, fragments of light combining into the first portrait of a stranger from another system. When morning arrived, the astronomers stepped outside to the cool air and looked up. The sky was already too bright to see their object, but they knew it was still there, moving silently through its arc. They had measured a piece of elsewhere and found it made of familiar elements, yet arranged in ways that told a different history. The confirmation that 3i Atlas was an active comet shifted the entire tone of the research. It meant that this interstellar traveler was not an inert fragment of rock, but a living archive of chemistry, a body that still responded to sunlight, venting ancient gases from beneath its crust. In the language of astronomy, it was not simply moving, it was behaving. That distinction transformed it from a passive object into a dynamic subject of study. Spectroscopic readings poured in from across the planet. The faint coma surrounding the nucleus was composed mainly of carbon dioxide, with traces of cyanogen and carbon monoxide. These substances had been frozen since the object's birth around another star, billions of years earlier. When the warmth of our sun reached them, they sublimated, escaping into space and creating the glow that marked 3i Atlas as a true comet. But there was something unusual in the ratios. Compared with comets native to our solar system, this one released far less water vapor and far more carbon-based compounds. It was a fingerprint of difference, a clue to the temperature and composition of the star system it came from. As the data accumulated, researchers noticed that the activity fluctuated. Sometimes the gas flow spiked, then fell silent again, as if the comet pulsed with faint rhythm. Those changes might have been caused by rotation or by uneven heating across its surface, or even by fractures in the crust where jets opened and sealed again. The uncertainty did not frustrate the scientists, it fascinated them. Every irregularity was a hint of texture, a sign that they were not studying an abstraction, but a body with shape and history. The discovery also settled an old argument. When Oumuamua, the first known interstellar object, passed through years earlier, its lack of a visible coma had triggered speculation. Some even wondered whether it could be artificial. But 3I Atlas restored balance to that narrative. Here was a clear case of a natural interstellar visitor, active, volatile, and beautifully ordinary in its physics. It proved that the galaxy is full of such wanderers, each a fragment of planetary formation flung outward into the void. Scientists began publishing their first brief reports. Titles were cautious: Preliminary photometric observations of 3I Atlas, Spectral analysis of a probable interstellar comet. Within those technical summaries ran a quiet current of awe. To hold a dataset from something that had formed around another sun was to bridge a distance that no spacecraft had yet crossed. Even as the public grew curious about the visitor from another star, astronomers resisted dramatization. The true story was already extraordinary enough. A piece of ice, born in the gravity of a distant system, had traveled for uncounted ages through darkness and cold until, by sheer chance, it passed close enough to the sun to reveal itself. It asked for nothing, gave nothing beyond what could be measured, and then continued on. In that sense, 3I Atlas was a perfect teacher. It reminded those who watch the sky that discovery does not depend on grand gestures, but on attention. By studying a single faint streak of light, humanity could read the chemistry of another world. As night fell again on Mauna Loa, the telescopes resumed their work, catching the subtle shimmer of the coma against the backdrop of stars. The air was still, the instruments patient. Somewhere out there, beyond the visible horizon, a traveler of frozen breath was shedding the first layers of its long silence. Determining where something comes from is one of the most difficult questions in astronomy. The sky holds motion, but not history. To reconstruct a journey, one must trace a path backward through time, across distances so vast that even small errors multiply into uncertainty. Yet for 3I Atlas, scientists could at least follow the direction of approach, the vector from which its light first entered our system. Using coordinated data from observatories on 3 continents, teams began projecting the orbit in reverse. They accounted for the gravitational influences of the Sun, the major planets, and even the faint pull of the outer gas giants. Each recalculation shifted the path slightly, but the overall direction remained consistent. The object had entered from the general region of the constellation Hercules. From that clue alone, astronomers could tell that it was not part of any known family of comets. It was a true outsider, unconnected to the long record of periodic visitors that circle back every few centuries. The calculations stretched backward, into epochs where human time loses meaning. To reach our neighborhood, 3I Atlas must have traveled for millions of years, perhaps longer. Its journey likely began in the outskirts of a distant solar system, a place where icy bodies form and are then ejected by the shifting gravity of larger planets. When such fragments are thrown free, they drift endlessly between stars, small, cold witnesses of creation. Some never approach another sun. A few, through pure coincidence, cross paths with places like ours. Tracing that route raised another question. What star system could have cast it out? No clear answer emerged. The galaxy contains billions of potential origins, and the object's age makes the trail irrecoverable. Stars move, drift, and reshape constellations over time. The place it came from may no longer exist as it once did. What remained was the knowledge that somewhere, long ago, a gravitational encounter had nudged this comet into a new trajectory, turning it into a messenger that would outlive its birthplace. For scientists, that uncertainty did not diminish the meaning of the discovery, it deepened it. In studying 3I Atlas, they were not simply observing one object, they were glimpsing the vast circulation of material across the galaxy. Every star system gives off such fragments, scattering its dust and ice into interstellar space. Over billions of years, those fragments wander, sometimes entering new systems, carrying traces of foreign chemistry. The Milky Way is not a static arrangement of stars, but a slow exchange of matter, a conversation of particles that crosses light years without end. As these ideas took shape in research notes and conference calls, the tone among astronomers remained both sober and quietly moved. The equations describing the comet's motion were precise, but their implications reached far beyond mathematics. Somewhere between one star and another, an object that began as dust and gas had become a traveler, and through the discipline of observation, that traveler had found witnesses. On the volcano, the telescopes continued their work. The mountain air trembled slightly in the early hours, a ripple of warmth rising from the rocks. The machines adjusted their focus to compensate. Light from 3i Atlas, now thousands of times fainter than the brightest stars, still reached their mirrors. Each photon carried the same message: I came from elsewhere, and I am passing through. In science, every new discovery gains meaning through comparison. To understand 3i Atlas, astronomers looked to its predecessors, the two interstellar visitors that had passed before it. The first, called Oumuamua, had startled the world with its strange shape and unexplained acceleration. The second, Borisov, behaved more familiarly, displaying a bright coma and tail like the comets long known within our own system. 3i Atlas stood between them, both in behavior and in symbolism, bridging the unknown and the understood. Oumuamua had been small, elongated, and puzzlingly reflective. It left no trail of gas, leading some to speculate about non-natural origins. Borisov, by contrast, was unmistakably a comet, active, volatile, and easily read through its emission lines. When 3i Atlas appeared, scientists expected something closer to Borisov, yet it carried its own surprises. Its coma was faint, more subtle than predicted, its spectrum rich in carbon dioxide but poor in water. It was a hybrid of sorts, not as cryptic as Oumuamua, not as radiant as Borisov, but wholly itself. This triad of discoveries revealed something profound. Interstellar visitors are not rare anomalies but natural participants in the life of the galaxy. Each detection expands the catalogue of what is possible. Before Oumuamua, the idea of observing a traveler from another star was a thought experiment. Now, within the span of a single human decade, 3 such objects had been recorded. The pattern suggested that the spaces between stars are not empty at all, but threaded with fragments of ancient systems quietly passing among one another. The physical differences between the 3 visitors also hinted at the diversity of planetary formation beyond the Sun. If Borisov resembled our comets and Oumuamua defied expectations, then 3i Atlas demonstrated a middle ground, evidence that the processes shaping distant systems are both familiar and strange. The building blocks of worlds, it seemed, were shared across the galaxy, but their proportions, temperatures, and chemical balances were endlessly variable. Each interstellar traveler was a sample from another experiment in creation. For the scientists who followed these objects, that realization carried emotional weight. The work itself remained quantitative: photometry, spectroscopy, orbit fitting, but beneath the equations lay quiet wonder. The same natural laws applied everywhere, and yet their outcomes produced infinite variety. To study 3i Atlas was to confirm that we belong to a universe both orderly and unpredictable. As papers and datasets circulated, a new tone appeared in scientific discussions: expectation. If 3 interstellar objects had already been found by telescopes not specifically designed to search for them, how many more were passing unnoticed each year? Improved instruments, more sensitive sky surveys, and faster data processing would likely reveal dozens, perhaps hundreds, in the decades to come. The interstellar era of small-body astronomy had begun. On the mountain, the night air thinned again as another sequence of exposures began. The operators, now accustomed to the visitor's faint signature, watched its movement in the logs without ceremony. The excitement of discovery had settled into the rhythm of study, the quiet stage that always follows revelation. 3i Atlas continued on its path, a pale thread of light crossing the background of fixed stars, neither as mysterious as Oumuamua nor as exuberant as Borisov, but essential precisely because it belonged to both worlds, the unknown and the known. Even with the largest telescopes on Earth, 3i Atlas remained a faint whisper of light. Distance, more than any other factor, defined the limits of what could be known. The comet was tens of millions of kilometers away, moving swiftly and reflecting only a small fraction of the sunlight that touched it. To capture a measurable image, exposures had to be long and steady, yet too much exposure blurred the object's motion. Every observation became a compromise between brightness and clarity, patience and precision. Astronomers often speak of distance not as an obstacle but as a teacher. It demands humility, reminding even the most advanced instruments that clarity has a cost. For 3i Atlas, that cost was uncertainty. Each telescope captured only fragments, a spectral line here, a dim fluctuation there. Some nights, clouds or high-altitude winds erased entire observation windows. Others yielded data so faint that analysts could not distinguish the comet's signal from background noise. In the archives, these imperfect readings were preserved alongside the clearer ones. To future researchers, they would speak of the effort it takes to reach beyond one's natural horizon. Still, the challenge united observatories across the world. From Chile's dry deserts to Spain's high plateaus, astronomers coordinated to fill the gaps left by weather, rotation, and daylight. The Earth itself became an instrument, its different longitudes forming a chain of watchfulness. When one night ended, another began elsewhere. In those overlapping intervals, a picture slowly formed, grainy, incomplete, yet undeniable. Through this collective effort, the object's path was mapped with extraordinary accuracy. But when scientists tried to resolve the comet's nucleus, it refused to reveal its shape. The coma blurred its edges, its small size defeated even the sharpest optics. It remained an abstraction, a coordinate, a motion, a curve in space defined by mathematics rather than image. Many found this fitting. Not every truth needs to be seen directly. Some are better understood through their effects. As data continued to arrive, computer models simulated the comet's probable appearance. It was likely a few hundred meters wide, irregular, perhaps fragmented. Some simulations suggested that it might already be breaking apart under the stress of sunlight and rotation. Others argued that it remained intact, a compact survivor hardened by eons of interstellar travel. No consensus emerged, and that uncertainty itself became part of the story. In scientific papers, the language reflected care. Words such as possible, estimated, and tentative appeared again and again. To the public, these qualifiers might seem hesitant. To scientists, they were marks of honesty, acknowledgements that the object's distance placed a boundary on certainty. The pursuit of understanding, they knew, is not defeated by limits. It is defined by them. As the comet moved farther from the sun, its brightness began to wane. The data grew thinner, the spectra quieter. Still, each observation mattered. Even the final, faint readings would help refine orbital models, improving the accuracy of future searches for interstellar visitors. On Mauna Loa, the Atlas telescopes continued their nightly rotations. They had already returned to their routine of scanning for potential Earth impactors, yet every few nights, an operator would glance at the coordinates of 3i Atlas, now slipping toward the edge of measurable space. To watch something fade is part of the practice, a reminder that knowledge, like light, diminishes with distance but never entirely disappears. The challenge of distance is, in the end, the essence of astronomy. Everything learned about the universe arrives from afar, carried by light that has already traveled across unimaginable emptiness. In studying that faint glow, humanity studies itself, its patience, its curiosity, and its enduring willingness to listen for what almost escapes perception. Once the orbit of 3i Atlas was confirmed, a formal bulletin went out from the Minor Planet Center. It was short, almost routine, a notice to astronomers worldwide to begin follow-up observations. Yet within the community, such messages are understood as quiet invitations, moments when the collective gaze of the planet shifts toward a single point in space. From Chile's Atacama Desert to the hills of the Canary Islands, observatories adjusted their schedules. Telescopes that had been pointed at galaxies and variable stars were retargeted toward the coordinates of the interstellar visitor. In South Africa, an optical array began capturing sequences of rapid exposures before dawn. Hours later, a team in Japan continued where the night had left off. The Earth itself became a turning network of attention, each longitude handing the observation to the next. Cooperation in astronomy often happens without words. Data files move silently through digital channels, timestamps align, calibrations are shared. Each observatory becomes a single eye in a global body of perception. For 3i Atlas, that coordination was immediate and instinctive. There was a sense of duty to document what the universe had briefly revealed, and to do so together. The first combined datasets arrived within days. The object's brightness had increased slightly as it approached the sun. Small differences in light intensity recorded from different sites confirmed that the detection was solid and consistent. With each new measurement, confidence grew, and the orbit refined. The mathematics that had begun on Mauna Loa were now validated across half the world. For those involved, the work felt different from ordinary observation. To look at a comet from another star system was to participate in something larger than measurement. There was a quiet awareness of privilege, to be alive in the moment when the universe chose to be visible in this way. No telescope or nation could claim ownership. The sky belonged to everyone who watched. Night after night, more instruments joined. Some measured spectra, others photometry. Even modest observatories contributed, their smaller mirrors gathering valuable data on brightness and position. Every photon counted. As the chain of observations tightened, it created a portrait of accuracy that would be studied for generations. Amid this collaboration, there was no sense of rivalry, no rush to publish first. The discovery was too brief, too precious for competition. The astronomers knew that what they were building was not a single paper, but a shared memory of the sky. Outside the observatories, most of the world went on unaware. The news had not yet reached beyond professional circles. While cities slept, a ring of telescopes traced a moving point across the heavens, each recording the same faint signal in slightly different light. In the combined view, the comet's story began to take shape. A journey written across continents, across languages, across time zones. And though the telescopes differed in size and design, they were united by a single truth, that knowledge grows best when attention is shared. The invitation to observe had become something deeper, an act of collective listening to the quiet voice of the cosmos. The coordination of global observation is a quiet triumph of human patience. No single telescope, no matter how advanced, can follow an object that crosses the sky as quickly as 3i Atlas. The Earth spins, clouds move, night never lasts in one place. To keep watch, astronomers must weave together the darkness of many horizons into one continuous fabric of attention. In practice, it begins with time, the most precise measurement humanity has mastered. Each observatory syncs its systems to atomic clocks accurate to billionths of a second. A signal travels through fiber networks, satellites, and radio waves to ensure that every image, wherever it is taken, can be aligned perfectly with every other. Without that harmony, the data would blur, and the object's path would be lost among the stars. Precision in time creates clarity in space. At the Keck Observatory in Hawaii, operators calibrate their instruments under a windless sky. In the Southern Hemisphere, technicians at the European Southern Observatory run parallel checks. Across the Pacific, the Subaru telescope confirms its filter alignments. Thousands of kilometers apart, they work as if in one room, each step following an invisible choreography. When the exposure sequence begins, the entire planet becomes a rotating camera, the night flowing from one continent to the next, like a slow tide of observation. In Spain, the Roca de los Muchachos telescope catches the comet as it climbs above the eastern horizon. Hours later, the same object appears in the early evening sky over Chile, and the handover continues. Japan takes the next shift, then Hawaii once more. The relay repeats, night after night, a planetary rhythm of light and mathematics. What began as a single detection has become a chain of coordinated watchfulness, bound not by language or politics, but by the simple agreement to look together. Each facility contributes its own strength. Large telescopes provide deep imaging with narrow fields of view. Smaller observatories fill in the gaps, capturing the wider movement that might otherwise be missed. Amateur astronomers join too, their backyard instruments calibrated by passion rather than funding. In the shared database, their images sit beside those from the largest professional facilities, equal in value once reduced to numbers. A photon is a photon, no matter whose mirror catches it. Behind the screens, the process is both delicate and routine. Raw data must be cleaned, filtered, and standardized before comparison. Temperature, humidity, and atmospheric distortion are logged. Each frame carries metadata, describing every condition under which it was taken. The task is meticulous, but the reward is certainty. When dozens of telescopes produce identical results, reality becomes undeniable. The collaboration also reveals something less technical: the discipline of humility. Each observer sees only a small fragment, yet trusts that the rest of the picture exists beyond their horizon. It is an act of faith grounded in method. The success of the project depends on believing that others, far away and unseen, are doing the same work with the same care. By the end of the first full week, the results begin to merge. A composite light curve emerges from overlapping observations, a smooth, undulating pattern showing how the brightness of 3i Atlas changes with time. Subtle dips and rises mark the comet's rotation, the irregular contours of its surface. To those who understand the graph, it feels like hearing the object breathe. When the first version of this curve is published, the accompanying text is only a paragraph long. It lists times, magnitudes, and observation sites. Yet behind those numbers lies the movement of continents, the shared pulse of effort spanning oceans. Humanity, for one small moment, had turned its collective instruments toward a single point of light and watched it cross the sky in unbroken sequence. In the stillness of the mountain night, the Atlas operators receive the compiled data and watch the lines appear on their screens. Smooth, continuous, precise. The object they first noticed is now part of a global collaboration. Its story has been woven from scattered fragments of light into one complete motion. Outside, the trade winds whisper across the volcanic slopes, carrying with them the hum of power lines and distant surf. Inside, the monitors glow softly, reflecting on quiet faces. What began as a single detection on a single night has become a planetary conversation, a demonstration that observation is not a solitary act but a shared human instinct. To look upward is to remember that knowledge grows best when spread across many eyes. And tonight, those eyes belong to Earth itself, turned together toward a traveler that will soon be gone but never entirely forgotten. Light carries secrets that no image alone can reveal. To understand what 3i Atlas was made of, scientists had to take that light apart, to stretch it, separate it, and read the colors hidden within. This is the purpose of spectroscopy, one of the quiet miracles of modern astronomy. With it, distance becomes less of a barrier. Even when a comet lies millions of kilometers away, its light can tell you what elements are present, how fast they move, and even the temperature of the gases that surround them. Across the world, teams began gathering spectra from 3i Atlas. Telescopes fitted with prisms or diffraction gratings spread its light into a thin rainbow and measured the intensity of each wavelength. Those rainbows were not continuous. They were marked by dark lines and bright spikes, fingerprints of atoms and molecules absorbing and emitting energy. Each line corresponded to a specific element. It was through these patterns that the story of the comet's chemistry slowly unfolded. The first spectra came from the Very Large Telescope in Chile. Despite thin clouds and unstable air, its instruments captured clear lines of carbon dioxide and faint traces of cyanogen, a compound often found in comets, but rarely in such concentration. A few days later, observatories in Japan and Hawaii confirmed the same signature, along with a near absence of the strong water vapor lines usually dominant in comets from our own system. The difference was unmistakable. This imbalance between carbon and water told scientists that 3i Atlas had formed under far colder conditions than the icy bodies orbiting our Sun. Somewhere in the outer reaches of another stellar nursery, well beyond the frost line, This fragment had condensed from gas and dust. It had then been flung outward by the gravitational tug of a forming planet, exiled into interstellar space. For countless ages it drifted, frozen and untouched, until chance brought it close enough to another star, ours, to warm again and reveal its composition. Every night, more observatories joined the effort. Data flowed through shared archives: brightness, values, atmospheric corrections, exposure times. In university labs, graduate students processed these files, aligning the spectral peaks and comparing them to laboratory standards. The work was slow and precise, like translating a language known only to light itself. Each line that matched a known element felt like a syllable recognized in a sentence written by the cosmos. Soon, the full chemical profile emerged. 3I Atlas was rich in carbon-bearing molecules, moderate in oxygen, and unusually low in nitrogen. Its ratio of volatile compounds suggested an origin region colder than any found near the Sun. To some scientists, it resembled the theoretical building blocks of exoplanetary systems still forming in the galaxy's outer arms. If that interpretation proved true, then this single comet was not just a traveler but a sample, a natural probe carrying material from places no human mission could ever reach. Spectroscopy also revealed subtler details. The width of each emission line indicated motion within the gas cloud, suggesting that the coma expanded unevenly. Some jets of vapor streamed away faster than others, meaning the nucleus was active in patches. Those variations implied a rotating surface, perhaps fractured or layered, releasing different gases as sunlight struck it from new angles. With each discovery, the object became less abstract. Though still invisible as more than a faint dot, its character took shape through numbers alone. In scientific meetings held over video links, researchers discussed their findings. Screens filled with colored graphs, peaks and troughs like frozen sound waves. Each person added a small piece, an adjustment here, a recalibration there, until a consistent portrait emerged. No single team owned the discovery. It belonged to the collective rhythm of shared curiosity. When the first joint paper circulated, its language was understated. Spectroscopic analysis indicates a carbon-rich, water-poor composition, inconsistent with solar system comets. For the scientists who read it, those words carried the quiet astonishment of success. They had used light, the most ephemeral substance, to study something older than the Earth itself. As the comet continued its journey, fading slightly each night, its light still carried across the dark, unchanged by time or distance. Those who studied it felt a form of intimacy with that light, as though they had glimpsed the hidden memory of another world. Spectra and signatures, the quiet language of elements, had spoken, and for a moment, humanity had understood. With the comet's chemical identity now clearer, attention returned to its journey, the graceful curve that carried it through our solar system. To trace that path was to glimpse the dialogue between motion and gravity, a conversation that had been unfolding for millions of years. Every object that travels near the Sun follows a line dictated by its speed and by the pull of all that surrounds it. For 3I Atlas, that line was open-ended, the geometric signature of an escape. Orbital analysts used thousands of data points collected from telescopes across the globe. Each image contributed a single coordinate in space and time. Together they formed an arc that could be extended both backward and forward, revealing where the comet had come from and where it would go next. The mathematics described a hyperbolic orbit, a smooth, ever-widening curve that would never close upon itself. The Sun could deflect its course, but not capture it. Computer simulations rendered that trajectory in quiet elegance. On digital screens, the comet's path appeared as a pale thread sweeping through the inner solar system, looping between the orbits of Mars and Earth before turning outward again. From one angle, it resembled a gentle bow. From another, it looked like a single stroke of light drawn across the void. Astronomers studied those models with reverence. Each data point represented the delicate balance between speed, distance, and gravity, a harmony of forces older than life itself. The calculations showed that 3I Atlas had entered the solar system from the direction of the constellation Hercules and would exit toward the southern sky, passing below the plane of the planets. Its closest approach to the Sun, the point known as the perihelion, would occur in early November of 2025. Around that time, the comet would shine at its brightest, still faint by human standards but accessible to telescopes across both hemispheres. Teams around the world began preparing for that moment. Observation schedules were adjusted, instruments recalibrated, and proposals for dedicated tracking programs approved. Every detail mattered. The comet's window of brightness would last only a few weeks, and then it would recede into darkness forever. The goal was to capture as much as possible while it remained within reach. In meeting rooms and virtual conferences, astronomers shared updated plots of the orbit. The figures were small miracles of cooperation. Each curved line was a collective creation, the product of thousands of hours of exposure, analysis, and cross-checking. What began as a faint signal on one mountain had become a global map of precision. Some scientists, in quieter moments, reflected on the meaning of that curve. A hyperbola has no return. It begins somewhere unseen and continues into infinity. To follow such a path is to embody impermanence. In that sense, 3I Atlas mirrored every transient thing in the universe, a reminder that motion itself is a form of passing. The comet's line through space was like a breath drawn once and never repeated. Others found poetry in the numbers. If plotted on a human timescale, the object's visit was a blink, a few months of visibility against millions of years of travel. Yet that blink contained all the knowledge humanity would ever have of it. The shape of its orbit was both its biography and its farewell. When the final model was shared with the community, it included more than just the trajectory. It showed the comet's velocity vector, the precise angle of solar deflection, and the influence of each major planet it passed. The details were intricate but harmonious. Gravity had bent the comet's path as sunlight bent its light, different expressions of the same cosmic law. As night fell again on Mauna Loa, the operators of the Atlas telescope reviewed the new orbital visualization. It spun slowly on their screens, a ribbon of light looping around the Sun and stretching away into the darkness beyond Neptune's orbit. The sight was strangely comforting. The mathematics were exact, the conclusion inevitable, yet the beauty lay in the pattern itself, the way the universe shapes motion without intent, creating art from precision. Outside, the wind moved softly over the volcanic rock. The mountain, the telescopes, and the travelers who watched the sky were all part of the same curve, drawn by the same gravity, momentarily close before continuing on their separate trajectories. For several weeks, the story of 3I Atlas remained quietly contained within the scientific community. Astronomers exchanged data, refined orbital plots, and spoke in careful tones about an event that, though rare, fit beautifully within the logic of celestial mechanics. But news, like light, has its own speed. Once the discovery reached public channels, the comet's calm journey was transformed into a subject of fascination, sometimes even myth. The first reports appeared in science magazines and observatory press releases. They described an interstellar comet, the third of its kind ever confirmed, discovered by telescopes designed to protect the planet from impact. The phrasing invited curiosity, a visitor from another star system, a messenger between worlds. Soon, mainstream outlets echoed the language, sometimes omitting the careful nuance that scientists prefer. Headlines spoke of mystery, signs of life, and a possible clue to alien chemistry. The scientists smiled politely at such speculation, knowing it was part of the public rhythm. Wonder always arrives before understanding. Yet for all the exaggeration, there was genuine awe in the reaction. People searched online for images of the faint traveler, even though none yet existed beyond long-exposure smudges. Amateur astronomers adjusted their small telescopes, hoping to glimpse what professionals could barely detect. Schools organized nighttime sessions, projecting digital simulations of the comet's trajectory on classroom walls. For many who looked up that season, the sky felt newly alive. It was not just a distant spectacle, but a shared mystery. proof that the universe still held surprises even in an age of satellites and constant information. In observatories around the world, the scientists continued their work with quiet focus, aware of the sudden attention but not distracted by it. Their responsibility was to the data, to accuracy and record-keeping. Still, a sense of pride slipped through the routine. Many had dedicated their careers to sky surveys that went unnoticed. To see their field momentarily illuminated in public imagination felt like recognition not of individuals, but of the collective act of looking carefully at the universe. Public engagement brought practical benefits too. Donations to astronomy outreach programs increased. Planetariums reported higher attendance. Social media filled with simple graphics explaining the difference between an asteroid and a comet, between an orbit and a hyperbola. Teachers described how their students, who rarely noticed the night sky, now asked questions about interstellar travel and cosmic chemistry. For a brief time, the story of 3i Atlas restored a kind of unity, an awareness that we all share the same sky, no matter where we stand beneath it. The scientists, for their part, took care to communicate the truth gently. Press statements avoided drama and emphasized patience. "This is a natural object," one astronomer said during an interview. "It is a reminder of how connected the galaxy is. Nothing here is isolated. Every system gives and receives material." Those words reached millions. In them, people heard something larger than science. The quiet suggestion that movement, exchange, and impermanence are the universal constants. Even as excitement grew, the comet itself remained distant and indifferent. It did not brighten dramatically or show a sweeping tail visible to the naked eye. It continued its steady path, a grey whisper against the stars. The contrast between the world's enthusiasm and the object's silence gave the event an almost meditative quality. For those who followed its progress, 3i Atlas became a symbol of perspective, the reminder that most of reality unfolds beyond perception, unnoticed yet ongoing. At the Atlas facility, where the discovery had begun, journalists requested tours. The operators guided them through the quiet domes, explaining the process with modest clarity. They showed the original images, pixelated but real, and the first log entry that had marked the object's detection. Visitors were surprised by the simplicity of it all. A small building, humming machines, a few screens, and a handful of patient observers. There was no drama, only discipline. And yet that discipline had revealed a path that stretched across interstellar space. When the visitors left and the mountain returned to silence, the astronomers resumed their nightly routine. Outside, city lights sparkled faintly below the clouds, while above, 3i Atlas continued on its invisible arc. News stories would fade in time, attention would turn elsewhere, but the comet's passage would remain written in data, a quiet entry in the long ledger of cosmic motion. The public's brief fascination had given something valuable, a reminder that science, even at its most technical, begins in wonder. It is the same impulse that makes children look up at the stars and ask what they are. Every telescope is an answer to that question, built not to end curiosity but to keep it alive. And as the world's gaze moved on, the astronomers kept theirs steady, watching the visitor glide toward the sun, serene and unchanged by the light of attention. When astronomers study a comet, they do more than analyze rock and ice. They read a record of formation. Each particle, each trapped molecule, carries the memory of a place where it once belonged. In 3i Atlas, that memory came from another star system altogether. It was a message not in words, but in motion, sent without intention, carried across the darkness by gravity alone. Scientists began to interpret what that motion could tell them about the broader structure of the galaxy. Every interstellar object that enters our system is a sample from elsewhere, a messenger of chemistry. Its speed, its angle of arrival, even the composition of its gases reveal something about how planets form around other stars. In that sense, 3i Atlas was not an intruder, it was a gift of evidence, a traveling archive of cosmic history. In laboratories and observatories, the collected data were transformed into models. Researchers simulated how such a body could be ejected from its home system. Most likely, billions of years earlier, It had orbited a young star surrounded by a disk of gas and dust. As large planets formed within that disk, their gravity scattered smaller objects outward. A few of those fragments escaped entirely, cast into the emptiness between suns. 3I Atlas was one of them, a wanderer that had crossed light years of cold silence before sunlight touched it again. This understanding reframed how scientists saw the galaxy itself. It was no longer just a field of stars separated by void, but a web of exchange. Matter travels between systems the way pollen drifts between flowers, seeding and reshaping the environments it touches. Each star both gives and receives, creating a slow conversation of material that never truly ends. The dust from one world may someday settle on another. In that sense, 3I Atlas was not a stranger but part of an ongoing dialogue, a single sentence in the language of galactic motion. The image resonated beyond the scientific world. Some writers described it as a cosmic handshake, others as a reminder of kinship across light years. Astronomers, though more restrained, felt the same quiet awe. Their discipline teaches caution, but it also rewards wonder. To measure something so distant and find in it the traces of connection is to feel both small and profoundly included. In meetings, researchers shared updates in calm tones, yet the subtext was unmistakable. They were seeing the Milky Way not as static architecture but as a living system. The comet's motion through our sky mirrored the flow of knowledge through their own community. Fragments of data traveling from mind to mind, each transformed slightly in interpretation, yet all moving in the same direction. At the Atlas Observatory, this realization took on a physical form. On the walls of the control room hung small maps showing the comet's trajectory. Lines of ink traced its movement from one constellation to the next, like a signature written across the heavens. Some of the scientists began calling it the traveler's message, half joking, half reverent. They understood that no one had written it, yet it said something nonetheless. That message, when translated into scientific terms, spoke of balance and impermanence. It said that creation and dispersal are not opposites but parts of the same cycle. The worlds that form around stars also shed fragments that carry their story onward. Even destruction, an impact, a scattering, becomes a means of continuity. The galaxy preserves nothing forever, yet forgets nothing completely. Late at night, when the data streams quieted, one could step outside and see the same stars under which the comet moved, invisible to the eye but present in awareness. The air was cold, the horizon sharp. Somewhere out there, the traveler followed its path with perfect indifference, yet its existence had drawn thousands of minds into alignment, all turning the same question over in thought. What else might be moving unseen between the stars? In that sense, 3I Atlas had already fulfilled its purpose. It did not need to linger or shine brightly. The message had been delivered, not through light, but through what light inspired. Its motion, traced by human attention, had reminded an entire planet that we, too, are travelers, circling our own star in endless motion through the galaxy's quiet sea. To know what something is made of is to glimpse the memory it carries. In astronomy, composition becomes a kind of biography, the record of where an object formed, what it encountered, and how long it has traveled. For 3I Atlas, that biography was written in frozen molecules older than any living species on Earth. Each grain of dust, each trapped gas bubble, was a letter in an ancient chemical alphabet, telling the quiet story of a world we would never see. Spectroscopy had already revealed the broad strokes. The comet was unusually rich in carbon dioxide, poor in water, and almost devoid of the nitrogen compounds common in comets born near our sun. But the details that emerged from continued observation added nuance. By measuring how sunlight reflected off the coma at different wavelengths, researchers began to map subtle color variations. Those hues suggested the presence of complex organics, long carbon chains, the raw materials from which life elsewhere might one day arise. None of this implied biology, only chemistry. Yet even chemistry, at this scale, felt like intimacy. From laboratories on Earth, teams compared the spectral data of 3I Atlas to the signatures of meteorites and cosmic dust collected by spacecraft. The differences were striking. The comet's ratios of carbon to oxygen and carbon to hydrogen were unlike anything seen in local samples. Its ice, if analyzed up close, would likely show crystalline structures formed at temperatures near absolute zero, the kind of cold found only in the farthest reaches of a star's protoplanetary disk. There, the feeble light of the parent sun can barely stir molecules into motion. The comet had been born in stillness, preserved in silence, and carried that memory within it. Astronomers sometimes describe comets as time capsules. They contain material unaltered since the earliest days of their formation. In the case of 3I Atlas, the capsule came not from our own history but from another star's beginning. To study it was to open a fragment of someone else's past, not someone human, but a world's. The thought carried a quiet reverence. In the data, scientists could trace not only physical properties but echoes of cosmic conditions far beyond the sun's reach. As new readings arrived, models of the comet's composition grew increasingly refined. Its dust grains appeared to contain silicates coated with organic films, the same pattern found in interstellar clouds where stars are born. This suggested that the matter composing 3I Atlas had spent ages drifting through a molecular cloud before being drawn into a forming system. That system had then expelled it, sending it on a journey that eventually led here. The comet was a record of multiple transitions, from cloud to disk, from system to void, from silence to discovery. For the researchers assembling these models, the experience felt like touching the edges of time. They could not see the comet directly, yet they could read its ancient chemistry with precision measured in fractions of a wavelength. Each measurement turned abstraction into connection. The past, normally unreachable, had left a trace in light, and light had crossed space to tell its story. The concept of chemical memory became a phrase repeated in conference presentations. It described more than just molecular composition. It suggested continuity. Matter remembers. Not in consciousness, but in structure, in the way bonds form, in the way energy leaves its imprint. The atoms inside 3I Atlas had experienced the birth and death of stars, had drifted through magnetic fields and dust clouds, had survived radiation, impacts, and solitude. They carried those experiences invisibly, as patterns frozen in their arrangement. When that idea reached the public through articles and documentaries, it resonated deeply. People understood instinctively that memory need not belong only to minds. The universe itself holds memory in matter, in motion, in light. The scientists who studied 3I Atlas had merely learned how to read it. On Mauna Loa, as the telescopes gathered their nightly data, the operators sometimes spoke softly about the object's journey, not with speculation, but with respect. They knew that every photon they captured had left the comet moments earlier, but the molecules producing that light had existed for eons. The connection between those times, between then and now, was thin as glass yet real. In that recognition lay a quiet humility. The comet was not a revelation, not a sign, but a reminder. The matter that drifted through interstellar space and the matter that built the observer's own bodies were made of the same ingredients, shaped by the same processes, only rearranged. To study the chemical memory of a distant traveler was to look, in a small way, into the mirror of origin. Every scientific discovery eventually reaches a boundary, the point where the instruments cannot see further, where data becomes uncertainty. For 3I Atlas, that limit arrived sooner than anyone wanted. The comet was moving quickly, fading as it traveled farther from the sun, and even the most powerful telescopes could no longer gather enough light for clear spectra. Its image blurred into background noise, dissolving into the same darkness from which it had once appeared. In that gradual disappearance, astronomers met the familiar edge of knowledge, not a failure, but the natural horizon of sight. Even within that limitation, there was beauty. Each uncertainty reminded the scientists of what makes their work honest. No image, no graph, no measurement is complete. Every conclusion is conditional. Every number carries an error bar. The precision of astronomy lies not in pretending to know everything, but in stating exactly how much one does not know. When the final observations of 3I Atlas were logged, they included long notes about atmospheric conditions, instrumental noise, and potential calibration drift. The margins of uncertainty were as carefully measured as the results themselves. In the control rooms, those who had followed the comet from the beginning watched its signal fade from their screens. The software continued to record, even when the readings fell below thresholds of confidence, because faint traces can still teach. Patterns sometimes emerge later, when technology improves. What one generation calls noise, another may call evidence. For that reason, every photon is archived. Back in their offices, researchers examined what the limits revealed. As the data thinned, the curves flattened, showing the quiet end of the comet's visible life. The coma that had once glowed with sunlight now dispersed into near invisibility. Models predicted that, at this stage, the object's gases had frozen again, sealing beneath the crust until the next encounter with a star, perhaps millions of years from now. The traveler was returning to sleep. The inability to see more did not frustrate the scientists, it steadied them. Astronomy has always been the art of partial vision. The universe reveals itself in fragments, a photon here, a pulse there, and invites humility with every glimpse. The people who watch the sky know that they are not writing complete stories but gathering sentences from a language too vast to master. There is a kind of peace in that incompleteness. On Mauna Loa, the team continued their nightly routines, recalibrating instruments, comparing their latest measurements to those of colleagues across the world. Though 3I Atlas had moved beyond reach, its trace remained in their shared archives. Numbers aligned across columns, timestamps stretching over months. The comet's departure had left behind a structure of collaboration, a map of human attention woven through time zones and languages. For those who had seen its faint light through the monitors, the memory was both technical and emotional. They remembered the thrill of the first detection, the slow accumulation of certainty, the realization of what it was, and now, the quiet acceptance of its fading. The life of an observation mirrors the life of what is observed. A rise, a presence, a decline. In that rhythm lies continuity. As the final data were archived, some wondered how future astronomers would interpret them. Would they see, in these imperfect numbers, the outlines of new knowledge? Would better instruments recover details hidden in the noise? The answer did not matter now. What mattered was that the record existed, that the effort had been made, and that curiosity had reached as far as it could go. Outside the observatory, the night sky looked the same as it had before the discovery. The stars shimmered above the volcanic ridge, the air thin and still. Yet for those who had studied 3I Atlas, nothing was quite as it had been. They had followed something that came from beyond the solar system, something that would never return, and had seen it only briefly. Its absence was not emptiness. It was proof that they had looked as far as they could. In the end, the limits of observation are not barriers but mirrors. They show where our reach ends and where wonder begins. Beyond the point where instruments fail, imagination continues, not as speculation but as respect, the acknowledgement that mystery too has its place in knowledge. After 3I Atlas faded from view, scientists began to look beyond the single object. They turned to statistics, to patterns hidden within the flow of discoveries that had come before. 3 interstellar visitors in less than a decade, Oumuamua, Borisov, and now Atlas, could not be coincidence. The universe, it seemed, was finally letting humanity glimpse something that had always been true. The space between stars is not empty. It is filled with travelers like these, silent fragments crossing the galactic current. Astronomers gathered at conferences and online symposia to discuss what the pattern meant. Using the rates of detection and the sensitivity of current surveys, they built models predicting how many such objects pass through our solar system each year. The numbers were staggering. For every interstellar comet observed, perhaps thousands more go unseen, too small, too dark, too distant for our instruments. The Milky Way may contain quadrillions of these wanderers, each one a remnant of formation, drifting endlessly from one star's influence to another. The realization reshaped the way scientists pictured the galaxy. It was no longer a static collection of isolated systems, but a continuous network of exchange. Every star expels fragments of its creation, and every star occasionally receives them. Over cosmic time, these fragments carry dust, ice, and the seeds of complex molecules across unimaginable distances. Matter travels freely where living beings cannot. In that circulation lies both continuity and renewal, a slow diffusion of possibility. For researchers, this was a profound perspective shift. The galaxy became a living system rather than a frozen map of lights. Stars were nodes in a grand ecology of motion. The discovery of 3I Atlas was not an isolated event, but evidence of an ongoing migration of material that links all planetary systems. To imagine that exchange is to imagine the universe itself breathing. In laboratories on Earth, computers translated these insights into simulations. Virtual galaxies blossomed on screens, billions of stars surrounded by faint halos of ejected material. Trails of light represented comets and asteroids drifting between them, a ceaseless migration like plankton in a cosmic sea. Scientists watched as those trails crossed paths, merged, and diverged again. The image was mathematical, yet deeply poetic, a visual proof that isolation is an illusion. Some researchers began comparing interstellar traffic to the flow of ocean currents on Earth. Just as the sea distributes heat, nutrients, and life across the planet, the galaxy distributes elements across its stars. Heavy metals from ancient supernovae become the building blocks of planets. Volatile ices, carried by comets like 3I Atlas, may seed young worlds with water and organics. The mechanisms differ, but the principle is the same. Nothing remains where it begins. Movement is creation. The Atlas team, reflecting on their small role in this vast process, took quiet pride in their contribution. Their instruments had been built to detect potential Earth impactors, yet they had ended up mapping the paths of interstellar messengers. It was a reminder that utility and wonder often overlap. Tools designed for safety can also reveal beauty. Meanwhile, new surveys were already being planned. The upcoming Vera Rubin Observatory in Chile promised to scan the sky more completely than any telescope before it. With its sensitivity and cadence, scientists expected it to find interstellar visitors regularly, perhaps several each year. The age of accidental discovery would give way to an era of deliberate detection. Humanity would begin to chart the incoming flow of matter from beyond the sun's domain, turning fleeting events into an ongoing science. In a sense, this pattern across the stars mirrored something human. Knowledge, too, travels freely, exchanged and transformed as it moves. Each generation of astronomers builds upon the fragments left by those before: data, equations, questions. The universe does the same with its material. It scatters, reuses, recombines. Every atom on Earth has been part of countless other structures. A star's core, a drifting cloud, perhaps even another living being. Late one night, an astronomer on the mountain paused between exposures and looked up from her monitor. The wind was low, the air thin and cold. She knew the sky above was full of unseen travelers, each carrying stories older than human thought. Somewhere among them, more comets like 3I Atlas were moving silently toward the sun, unseen for now but inevitable in time. That awareness brought a strange peace. Discovery, she realized, is not about rarity, but recognition. The patterns had always been there, only our instruments had grown sharp enough to notice. The stars, it seemed, had been exchanging gifts for as long as they had existed. The galaxy was a vast conversation, and for the first time, humanity had begun to listen closely enough to hear the rhythm of its speech. When the final, confirmed measurements of 3I Atlas were filed, a rare stillness followed. Months of constant observation, communication, and calculation had given way to silence. The screens no longer glowed with new data, and the instruments turned once again to their usual surveys. Yet something had changed, not in the heavens, but in the people who had watched them. The experience left behind a quiet realization: the most valuable discoveries are not always about what is found, but about what they reveal within those who search. At first, that awareness felt subtle, the kind that lingers at the edge of thought. The comet had come and gone, leaving only its recorded trail. But the deeper reflection arrived slowly, much as dawn climbs over the ocean, illuminating the landscape without sound. Scientists began to sense that the true significance of Three-Eye Atlas was not its rarity, nor its chemistry, nor even its interstellar origin. It was the perspective it offered. For a fleeting season, thousands of people across continents had shared a single point of focus. Nations, institutions, and individuals had synchronized their attention on one faint traveler moving through the sky. That collective gaze, more than the data itself, had become the real discovery. In an era defined by division and noise, the sky had once again served as common ground. The same light that touched the telescope mirrors in Chile reached those in Hawaii, in Spain, in South Africa, in Japan. It crossed every border without hesitation. The scientists who followed it did the same in spirit, joined not by language but by precision and patience. What they had measured was an object of ice and dust. What they had experienced was unity. This awareness surfaced in small ways. During an online symposium, one astronomer remarked that they had spent weeks collaborating with colleagues whose faces they had never seen. "The comet was the introduction," she said softly. "Now we speak as though we've known each other for years." Others nodded. The work had built relationships invisible in the data but enduring beyond it. The object that came from beyond the sun had drawn together minds from every horizon beneath it. As the comet receded into darkness, telescopes turned to new tasks. Yet researchers found themselves returning to the archived images, the delicate curves of its trajectory, the signatures of its light. They no longer studied them for results but for remembrance, to recall the feeling of participation in something vast and fleeting. The numbers represented both knowledge and gratitude. Outside the observatories, the public attention that had once burned brightly began to fade. The headlines disappeared, replaced by other stories, other urgencies. But within the community of watchers, the stillness remained. In that stillness lay understanding. That observation is an act of humility. To look at something so distant, to know it will never return, and yet to study it with care, is to practice reverence without expectation. For some, that realization expanded beyond the scientific. The passage of Three-Eye Atlas became a metaphor for transience, for the way lives, moments, and discoveries appear, glow briefly, and move on. A senior astronomer compared it to listening to music carried on the wind. You hear only a phrase, never the whole song, yet that fragment changes the silence that follows. At the Atlas Observatory, the mountain returned to its rhythm of darkness and light. The hum of the equipment blended again with the faint rush of wind across volcanic rock. But those who worked there found themselves pausing more often between tasks, stepping outside to look at the horizon before dawn. The sky was the same, yet their awareness had shifted. They now understood that every patch of stars might hold another traveler, unseen for now but approaching quietly. In meetings and papers, the term interstellar object remained technical, but in conversation it acquired a different tone, less clinical, more affectionate. It no longer referred only to icy fragments crossing gravitational fields, but to the shared recognition of impermanence and connection. Each discovery was a reminder that our solar system is porous, our isolation an illusion. The quiet realization born from Three-Eye Atlas was simple but enduring, that science at its core is an act of attention. It asks only that we notice, record, and remember. The universe speaks in motion, and those who listen become part of that motion themselves. The comet had passed, the data had ended, but the listening that would continue, as it always does, in the silence after the light. When the calendar turned to early November of 2025, the comet reached the heart of its journey. Astronomers called it the moment of perihelion, the point at which Three-Eye Atlas passed closest to the sun before beginning its long retreat into the dark. The word itself carried a kind of poetry, a single instant of nearness within an orbit that would never return. Telescopes around the world stood ready. Instruments had been checked, calibrated, and synchronized to atomic time. The energy of sunlight now falling upon the comet's surface was nearly double what it had been months earlier. At that distance, ice did not melt so much as sublimate, vanishing directly into vapor. Jets of gas erupted from fissures in the nucleus, carving invisible arcs of motion through the void. For a few days, the comet brightened slightly, glowing faintly against the black of space, like a thread of smoke caught in a beam of light. In Chile, observers at the Paranal Observatory caught the first confirmed images of this outburst. On their screens, the coma appeared slightly expanded, its outer edges trembling as new material streamed away. Within hours, the same feature was recorded from Hawaii and then from telescopes in Japan, confirming that the event was real, not an artifact of atmosphere or equipment. The traveler was still alive, still responding to the warmth of the star it had never known before. Spectra gathered during this brief window revealed subtle changes in composition. Carbon dioxide remained dominant, but traces of methane and acetylene appeared for the first time. These gases had likely been trapped in deeper layers, exposed only now as sunlight penetrated beneath the outer crust. Their presence told of ancient chemistry, molecules that had formed when another star was still young and its planet still gathering from dust. Each release was a whisper from that forgotten place, carried across light years only to dissolve in our sky. For those who had studied the comet from its discovery, the moment was both exhilarating and bittersweet. They knew it would not last. Already the object was moving faster, pulled by gravity into a sharp curve that would fling it outward again. Within days, it would begin to fade beyond the limits of most instruments. But for now, for this narrow sliver of time, the universe allowed a final look. At the Atlas Observatory, the night was calm and clear. Inside the dome, soft red lights illuminated quiet faces bent over monitors. On the screens, the comet's position shifted slowly, its brightness climbing to a peak measured not by sight but by numbers. Outside, the volcanic air smelled faintly of sulfur and cold stone. The sky above was rich with stars, but the astronomers' eyes remained on their instruments. They did not look up. They were already watching something far greater than sight could reach. At sunrise, they stepped out into the golden light. The Pacific shimmered far below, a sheet of silver stretching to the horizon. The comet, now invisible in the glare of day, was rounding the sun, its trajectory bending toward the edge of the solar system. It would spend the coming months ascending into the northern sky, fading as it went, until it disappeared beyond detection entirely. The data they had gathered during this passage would become the final chapter in its measurable story. When the last images arrived, they were faint and grainy, almost lost in the noise. Yet they held the proof that the object had survived its encounter. It had not broken apart or vanished. It had endured, altered but intact, carrying on into the cold once more. That endurance touched something human in those who watched. Against vast odds and endless distance, the traveler had come close, revealed itself, and continued onward. Later, in quiet discussions, an astronomer described the experience simply: it passed, it spoke in light, and then it went home. The words lingered. The comet's passage near the sun had been brief, but it had compressed into that instant the essence of all: motion, approach, revelation, departure. As the sun set that evening, the telescopes turned to new coordinates. Yet those who had witnessed the event felt a presence that would not fade. Somewhere beyond the inner planets, 3i Atlas moved silently through the cooling dark, its gases refrozen, its message complete. The Earth turned beneath the same sunlight that had touched it, and for a moment, everything felt connected: the star, the stone, and the watchers who had traced the curve between them. After the comet passed the sun and began its outward journey, the pace of observation slowed. The excitement of discovery, the rush of coordination, the bright spike of perihelion, all receded into a quieter rhythm. 3i Atlas was moving away from the warmth now, back into the vast cold that had shaped it. Its coma, once gently luminous, thinned each night until it vanished entirely. All that remained was a dim point of reflected light, slipping steadily toward the edge of measurable space. At first, telescopes still tracked it nightly. Even as its brightness fell below the threshold visible to small instruments, larger observatories continued to record faint signatures, verifying the predictions of its trajectory. Each new data point confirmed what mathematics had already told them: the visitor would not return. Its velocity was too high, its orbit open forever. The sun's gravity had merely bent its path, not captured it. In the control rooms, the sense of farewell arrived not as drama but as acceptance. The last images were faint, sometimes no more than a few pixels above background noise. Yet within those pale traces lay months of human attention, the sum of countless hours spent aligning mirrors, adjusting exposures, cleaning data, and comparing results. Every photon recorded was a goodbye written in light. By December, 3I Atlas had moved far beyond the orbit of Mars. The intensity of sunlight striking its surface had dropped sharply. Temperatures around its nucleus fell again toward the deep freeze of interstellar space. Whatever jets of gas still remained quickly ceased. The comet returned to its dormant state, wrapped once more in silence. For the first time since its arrival, it was again what it had always been, a frozen traveler between stars, carrying within it the chemistry of a place now unreachable. The astronomers continued to publish their findings. Each paper represented another form of farewell, a final translation of raw data into meaning. They described the object's trajectory, its composition, its unexpected brightness variations. They compared it to Oumuamua and Borisov, noting how each differed yet pointed to the same truth. Interstellar space is filled with motion. These summaries closed the chapter with precision, but also with something like tenderness. Facts alone could not express what it meant to have witnessed a fragment of another world drift through our own. For the general public, the story of the comet faded quickly, replaced by new events and new discoveries. But among those who had studied it, its presence lingered. Even months later, conversations would drift back to that faint streak of light. "Do you remember the nights we waited for a clear window?" someone would say. Or, "I still think about that first spectrum, how strange the ratios were." It became a kind of shared memory, a quiet thread, connecting people who might never meet again but had once watched the same traveler pass through the dark. The observatories returned to their usual rhythms. The Atlas system resumed its nightly scans for asteroids that might threaten Earth. The same instruments that had caught an interstellar messenger now searched once again for local dangers, yet something intangible had changed. Every operator who worked beneath those domes now knew that the sky they monitored was not sealed. Beyond the known orbits of planets and comets lay a wider traffic, unseen but constant, fragments from other stars passing through our awareness like echoes in a long corridor. As the new year approached, one of the senior astronomers wrote a short reflection for a scientific newsletter. "The end of an observation," she wrote, "is not an ending at all. It is simply the moment when the universe asks us to remember." Her words captured what numbers could not, the sense of continuity that comes from paying attention. The comet had left no physical trace, no tail visible to the naked eye, no dust that would rain upon the earth. Its only imprint was within those who had looked for it, a pattern of thought, a reminder of connection. And so, the farewell was not one of loss but of understanding. The visitor had passed through, leaving the solar system precisely as it had found it. Yet the observers had changed. They had glimpsed the movement of the galaxy through a single grain of ice and dust, and in doing so, had seen themselves as part of that same movement. The last formal observation of 3I Atlas came from a telescope in Spain. The image was faint, almost indistinguishable from background stars. Still, the team recorded it, labeled it carefully, and added it to the archive. Then they closed the dome and turned off the lights. The traveler was gone, its path continuing beyond sight, but its presence lingered in the still air, a soft echo of motion, a long farewell written not in sound but in patience. Every discovery leaves behind a residue of meaning, something that cannot be measured yet remains. When 3I Atlas disappeared into the outer dark, the scientists who had watched it began to reflect on what it had taught them, not in numbers or graphs, but in understanding. The comet had been a visitor from elsewhere, uninvited yet deeply revealing. Through its presence, the observers learned something about the universe, and perhaps something about themselves. The first lesson was humility. For all the sophistication of instruments and equations, there were limits that no technology could overcome. The comet had passed through the solar system in perfect silence, carrying information that could never be fully recovered. Its composition, its shape, the exact details of its origin, all would remain partially unknown. In that unknowing, however, lay the essence of astronomy. To study the sky is to accept that certainty will always be partial, that the beauty of discovery lies not in completion but in pursuit. The second lesson was continuity. 3i Atlas reminded humanity that nothing in the cosmos exists in isolation. The same processes that shaped our planets also shaped the worlds around distant stars. Matter travels, transforms, and returns, building complexity through endless circulation. The visitor's chemistry, its strange carbon dominance, its scarcity of water, told a story of differences, yet those differences belonged to the same grand pattern. The comet was foreign, but not alien. It followed the same laws that govern everything. The third lesson was patience. The study of 3i Atlas unfolded over months of careful coordination. Data gathered, processed, compared, and refined. Each observation required attention to detail and trust in others. There was no single discovery moment, no instant revelation. Instead, knowledge grew through persistence, the slow accumulation of small truths. That rhythm mirrored the universe itself, where change occurs not in leaps but in gradual motion, each orbit a continuation of what came before. Beyond these scientific insights lay something quieter, a sense of perspective. Those who worked closest to the comet's data spoke often of scale. A fragment no larger than a city block had traveled between stars, crossing distances that defy imagination, and yet it had been visible to human instruments. That fact alone was enough to shift the sense of proportion. Human lives seemed brief and local, yet they could reach across the galaxy through light and thought. The comet's passage reminded its observers that awareness itself is a form of participation, that to know of something is already to be connected to it. When the international reports were compiled, one of the summary papers began with a line that would later be quoted in lectures. The object designated 3i Atlas represents not an exception, but a continuation of natural exchange between stellar systems. The sentence was scientific, but between its words rested something almost philosophical, that our place in the cosmos is not central but shared. Every star, every planet, every traveler participates in the same quiet network of movement. For students and enthusiasts who followed the event, this idea held a special resonance. The comet became a symbol of interconnection, often used in documentaries and lectures as an illustration of how material and meaning travel together. In classrooms, educators described it as the proof that the galaxy breathes. It was both literal and poetic, an expression of physics that also touched emotion. Back at the observatories, the lesson endured in subtler ways. Teams that had once operated separately now shared data more freely, applying the collaborative methods developed during the comet's tracking to new projects. The spirit of shared curiosity that 3i Atlas inspired did not fade when the comet vanished. It had become part of the working culture. Its influence extended into how astronomers spoke, wrote, and even designed new instruments, all shaped by the reminder that knowledge grows through connection. Late one night, months after the last observation, an astronomer stepped outside the dome to stretch his legs. The air was cold and sharp, and the stars hung low and steady above the horizon. Somewhere out there, 3i Atlas was still moving, silent and small, a pinpoint of frozen memory. He thought of how it had appeared without warning, how it had taught so much by saying nothing. Looking up, he whispered the words that had come to define the project. Everything travels. The phrase carried more truth than poetry. Light travels, matter travels, thought travels. In the space between those movements lies meaning. The comet had been a traveler of substance. The scientists were travelers of understanding. Each, in its own way, moved through the same vast continuum. That recognition, simple, profound, and complete, was the lasting lesson of the visitor called 3i Atlas. All that remained of 3i Atlas was data, billions of numbers arranged in long columns, stored across servers on multiple continents. Yet within that digital quiet rested the full memory of its visit. Light, captured and converted, had become record, Each photon that once left the comet's surface now existed as a value in a table, a small dot in a graph, or a line on a spectrum. It was easy to mistake this for abstraction, but to the astronomers who had gathered it, the archive felt alive. It was the comet translated into human language, motion turned into knowledge. At the Atlas Observatory, the data from every exposure was carefully verified before being sent to international repositories. The images, though grainy, held remarkable consistency. They showed how the object's brightness had risen near the sun, how its color index had shifted, and how the coma had expanded and faded. These patterns were subtle, almost imperceptible to untrained eyes, yet together they formed a complete narrative. To anyone who understood the code, the comet's story could be read frame by frame. Around the world, research centers received copies of this information. The European Space Agency stored it alongside data from other interstellar bodies. The Harvard-Smithsonian Center for Astrophysics catalogued it within their Minor Planet archive. University groups used it for thesis work, training new generations of students in orbital dynamics and spectroscopy. The light that had once crossed billions of kilometers now trained minds that had never seen a telescope dome in person. In that sense, the comet had not vanished at all. It had simply changed form, from matter to light, from light to data, from data to learning. The archive was more than preservation, it was conversation. Each dataset inspired new questions. How many interstellar objects might exist unseen? What does their composition reveal about the temperature of distant stellar nurseries? Could the chemistry of such bodies explain the early stages of planet formation? None of these questions had simple answers, but each extended the dialogue that 3i Atlas had begun. The comet had become a reference point, a standard against which all future visitors would be compared. Astronomers often spoke about light as if it were memory itself. A star's glow carries the image of its past. A comet's reflection reveals the surface it once hid. In the laboratory, those truths took shape through calibration and mathematics, yet they retained a certain poetry. Light does not keep secrets, it only waits for the right instruments to translate it. Every dataset in the archive was a translation of silence into understanding. Years from now, long after the comet's name faded from headlines, its photons would still be read. Each time a student opened those files, the universe would speak again through the faint shimmer of recorded light. And perhaps, in that act of analysis, a new connection would be made. A fresh question, a novel insight, another small bridge across the unknown. In this way, the archive kept the conversation alive, not as nostalgia but as renewal. For the team who had gathered the data, that was the quiet triumph. The world would move on, the night sky would change, but their work would endure in invisible form. The signals they had captured were more than measurements. They were a trace of attention. Every line of code, every correction, every verified timestamp was an affirmation that curiosity had been here. The universe had spoken, and someone had listened closely enough to write it down. When the final transfer was complete, the Atlas team held a small, unannounced meeting. There were no speeches, no ceremony, only a moment of shared silence as the last files uploaded to the global servers. The leader of the project finally said, "That's it. It's home now." Locking Wise and Rees. Outside, the mountain was dark except for the faint red glow from the domes. The stars above shone with the same calm indifference as always. Yet for those who had spent months watching one small point of light, the night no longer felt indifferent. It felt full, full of memory, full of meaning, full of the quiet hum of data becoming knowledge. Somewhere beyond the planets, the traveler continued its endless flight. Here on Earth, its light had settled into permanence, safely archived, waiting for future eyes to read its story anew. Discovery rarely ends when the object vanishes. It reverberates through conversations, through new hypotheses, through the subtle shifts in how people think about the world. Months after 3i Atlas had faded beyond reach, its influence could still be felt in the quiet momentum of science. The comet was gone, but its echoes remained, in papers being written, in instruments being redesigned, in the way researchers described the sky itself. At the annual astronomical congress that spring, one session was devoted entirely to interstellar objects. The room filled early. Some attendees had been part of the original observation network. Others were students who had followed the discovery from afar. On the screens behind the speaker's podium, images of 3I Atlas appeared, faint, grainy, almost abstract, yet the audience watched them as though they were portraits. Those indistinct dots represented everything humanity had learned about a traveler from another star. The presentations that followed reflected a newfound sense of continuity. Instead of asking whether interstellar objects existed, the question had become how many and how varied they might be. Speakers proposed networks of automated telescopes that could catch such travelers earlier and track them longer. Engineers discussed software capable of identifying faint motion across wide fields of view. The energy in the room was quiet but unmistakable, the sense that something immense had just begun. In the hallways between sessions, conversations turned philosophical. "We used to think of the solar system as a boundary," one researcher said to another. "Now it feels more like a hallway." The remark drew nods and smiles. The concept of isolation had shifted. The space between stars no longer seemed like emptiness, but like the connective tissue of a living structure. For the Atlas team, the echoes took a more personal form. They began collaborating with groups they had never worked with before: meteor scientists, planetary chemists, even data theorists. Each new connection traced back, directly or indirectly, to that faint streak of light discovered one evening on Mauna Loa. The comet had changed not only knowledge, but relationships. It had reminded people that science grows strongest when curiosity is shared. Outreach programs soon followed. A documentary aired showing how the discovery had unfolded, interspersing footage of observatories with interviews about the human experience of wonder. Viewers were surprised to learn how much patience, not excitement, defined the process. "It's mostly waiting and checking," one astronomer said in the film. "And yet when the pattern finally appears, you feel as though you've heard the universe exhale." The phrase spread online, quoted by students and journalists alike. It captured something timeless, the quiet release that comes when mystery reveals just enough to prove it was real. Meanwhile, in laboratories and classrooms, the data from 3I Atlas continued to inspire. A graduate student in Japan analyzed its spectral lines to refine models of carbon formation in cold stellar disks. A professor in Finland used its orbital parameters to teach about gravitational deflection. A small university observatory in Chile began a citizen science project inviting volunteers to review old survey images in search of other interstellar visitors. The echoes of discovery had become education. Even the public, though no longer focused on the story, carried fragments of it. In a world often preoccupied with what is near and immediate, 3I Atlas had provided a glimpse of perspective. It had reminded people that the universe extends beyond comprehension, yet remains accessible through attention. Many who had read about it months before now found themselves looking up at night with new curiosity, wondering what else might be passing unseen overhead. In time, the excitement around interstellar comets would normalize. They would cease to be front-page news and become part of the steady rhythm of science. But the first few discoveries, Oumuamua, Borisov, Atlas, would always hold special meaning. They marked the moment when humanity stopped thinking of the stars as separate realms and began to see the galaxy as one continuous landscape of motion. At the end of the conference, the final speaker summed it up simply: "Each of these visitors leaves behind more than data. They remind us that discovery is not an event, it's a habit." The audience sat in silence for a moment, not out of solemnity but recognition. That habit, once learned, changes the way the world is seen. As night fell outside the conference hall, some attendees lingered to watch the first stars emerge. None of them could see 3I Atlas anymore, but they knew it was still out there, somewhere in the dark, carrying the quiet echo of their own curiosity back into the spaces between suns. The story of 3I Atlas did not end with its departure. It marked the beginning of a new way of listening to the cosmos. Until recently, astronomy had been an art of seeing, of capturing images, charting orbits, and measuring brightness. But after Atlas, the idea of observation expanded. Scientists began to speak less about sight and more about hearing, not in sound, but in awareness. Every telescope became an ear, tuned to faint messages carried by light, gravity, and time. In laboratories and control rooms, this shift was more than metaphorical. New instruments were being designed to listen differently. Radio arrays sensitive enough to detect molecules between stars, space telescopes capable of tracing interstellar dust trails, and artificial intelligence systems trained to recognize unusual motion across vast data sets. All grew from lessons learned during the tracking of 3I Atlas. The visitor had shown that discovery requires attention not only to the bright and obvious, but to the small, the quiet, the almost invisible. This philosophy began shaping the next generation of observatories. The Vera Rubin Observatory in Chile, nearing completion, embodied it completely. With its enormous digital camera, it would scan the entire sky every few nights, creating a moving archive of change. The data it gathered would be so vast that no human could study it all directly. Algorithms would become partners in listening, trained to recognize patterns of movement that might signal another interstellar traveler. The idea was not to search narrowly, but to remain open, to listen without bias. Scientists started referring to this approach as continuous awareness. Rather than waiting for something extraordinary to appear, the system would maintain constant vigilance, treating every photon as potentially meaningful. This principle, born from the discovery of one faint comet, soon influenced how researchers approached other fields: exoplanet detection, supernova tracking, even the monitoring of near-Earth asteroids. The distinction between routine and remarkable began to blur. Everything, it turned out, was part of the same ongoing conversation between the Earth and the sky. In interviews, the Atlas researchers often returned to the same reflection. We didn't find the comet. It found us because we were listening. The phrase captured the humility and wonder of the project. Discovery was not conquest, but connection. The universe was not hiding its secrets, it was speaking constantly. The challenge was to quiet human noise long enough to hear. Beyond science, the idea resonated in unexpected places. Writers, artists, and educators began to use the story of 3I Atlas as a metaphor for attention, for how awareness transforms experience. In classrooms, teachers compared the astronomer's patience to the act of deep listening in daily life, the stillness required to notice what usually passes unnoticed. In this sense, the comet had become a symbol of mindfulness as much as of cosmic motion. For the scientists, though, the lesson remained practical. They built tools designed not just to record, but to respond. Systems were programmed to trigger automatic follow-ups whenever an unidentified moving object appeared. A telescope in Hawaii might detect a faint streak. Within minutes, observatories in Australia or Chile would receive coordinates to verify it. The process was seamless, a planetary nervous system for cosmic listening. Late one night, an astronomer at one of these observatories opened the archive of 3I Atlas once more. The data was old now, yet it still carried the same quiet pulse. The graphs and spectra no longer represented work. They had become reminders of attention well spent. Outside, the wind brushed across the dome. The sky was clear, the air thin. Somewhere out there, new travelers were moving, unseen for now, already on their way. He smiled at the thought that when the next one arrived, humanity would be ready, not with noise or haste, but with patience, with instruments tuned to silence, with minds prepared to listen. The story of 3I Atlas had not been a conclusion, but a rehearsal. It had taught that the universe is not a mystery waiting to be solved, but a presence waiting to be heard. And so the future of astronomy, shaped by a single comet's passing, became a future of listening, not of reaching outward with demand, but of opening inward with curiosity. The instruments would change, the discoveries would multiply, but the essence would remain. Attention as reverence, perception as connection, discovery as dialogue. Somewhere between the stars, the next voice was already speaking, softly, patiently, endlessly. Behind every discovery, beneath the data and the mathematics, there is a human thread, the continuous line of thought, patience, and emotion that binds generations of observers together. The story of 3I Atlas, though framed in equations and measurements, was ultimately a human one. It revealed how curiosity moves through people the same way comets move through space, quietly, persistently, passing from one mind to another, never staying still. For the scientists who worked under the domes, this realization came gradually. After the comet had left and their instruments returned to routine tasks, they noticed how the experience had changed them. It had made them slower, more deliberate. The long hours of waiting, the nights of uncertainty, had trained them to find meaning in silence. The object they studied had been indifferent to their presence, yet it had drawn out their best qualities: precision, humility, and wonder. Some of the younger astronomers spoke of the project as a kind of mentorship. The older researchers had taught them not only how to interpret spectra or calculate orbits, but how to carry themselves through uncertainty. "The universe doesn't rush," one senior scientist often said, adjusting the focus knob on the telescope. "So neither should we." That sentence became a quiet motto among the students who worked those nights. It summarized what the comet had given them: perspective. The human thread stretched beyond the observatories. Data analysts who had never looked through a telescope still felt part of the journey. Their algorithms had helped track the traveler across millions of kilometers. Engineers who had designed the sensors took pride in knowing their instruments had touched light from another star system. Even the administrators who handled funding requests and logistics began to speak of the project with gentle affection. The discovery had become communal, a shared story told through the language of numbers. This sense of connection deepened when letters and messages arrived from the public. Some were from students who had followed the news and now wanted to study astronomy. Others came from ordinary people moved by the idea of something crossing between stars. One message read simply, "It makes me feel less alone, knowing that even rocks can travel so far." The scientists pinned that line to a corkboard inside the control room. It reminded them that the meaning of their work extended beyond research papers. It touched imagination. In meetings months later, as new projects began, the influence of 3i Atlas could still be felt. The teams communicated differently, more openly. There was less rivalry, more collaboration. The comet had taught them that no single person could claim ownership of discovery. Every observation depended on countless invisible contributions: technicians, programmers, observers, students, all woven together into one continuous awareness. The science had been global, but the connection had been human. Some of the researchers, returning home after long months on the mountain, found the night sky altered in their perception. They no longer saw random points of light, but a network of histories. Every star, every faint glimmer, felt alive with potential. Each one a place that might someday send another traveler our way. They would look up from city streets or quiet gardens and imagine unseen objects passing overhead, remnants of worlds long gone. In that awareness was comfort. The sky was not distant anymore. It was participation itself. In quiet moments, one of the lead scientists kept returning to a thought that had come to him during the height of the observations. "The data connects us, but curiosity is what holds the line." He had written it in a notebook and forgotten it until months later, when he found the page again. Reading it, he realized it was true not only for astronomy, but for every form of learning. Curiosity was the thread that tied everything together, from the earliest stargazers drawing constellations in the sand, to the modern instruments scanning galaxies in digital precision. The comet had passed, but the thread it had pulled remained unbroken. Every researcher who had touched its light had been added to a lineage stretching back through centuries, from Galileo peering through his handmade lenses to the teams that now built telescopes across entire mountains. Each generation listens a little further, sees a little deeper, guided by the same desire: to know what moves through the dark. As night fell again over Mauna Loa, the domes of the Atlas Observatory turned silently toward the sky. New surveys began, fresh coordinates filled the screens, and the rhythm of observation resumed. Yet beneath the surface, something intangible had shifted, a continuity, a thread of awareness connecting those who watch, those who listen, and those who dream. The traveler from another star had come and gone, but the people it touched remained bound by the same light, still tracing the same endless curve of curiosity through the dark. Far beyond the orbit of Jupiter, where sunlight becomes thin and cold, 3I Atlas drifted into silence once more. The last faint heat from its brief passage near the sun was gone, its gases frozen solid, its once bright coma collapsed inward. Around it stretched a space so empty that the next grain of dust might lie millions of kilometers away. No telescope could see it now. The only evidence that it existed remained in archives of light and memory. Yet the comet continued its motion with perfect precision, indifferent to distance or attention, moving through the dark as it had always done. Astronomers knew, at least mathematically, where it was. The orbital models, plotted with exquisite care, predicted its position to within a few thousand kilometers, a pinprick on a vast map of emptiness. Each simulation showed it gliding outward on its hyperbolic curve, escaping the sun's gravity, carrying its silent cargo of frozen molecules back into the deep interstellar medium. Eventually, the light of the sun would shrink to a single bright star behind it, just one among billions. Ahead lay nothing but the invisible currents of galactic motion, the slow swirl of dust and gas between worlds. For those who had studied it, imagining this journey became an act of meditation. They pictured the comet tumbling gently through the dark, its rotation slow and steady, its surface faintly illuminated by distant starlight. The jets that had once sprayed vapor into space were sealed again beneath a crust of ice. No sound accompanied its passage, no vibration, no wake, yet its motion was absolute, a line drawn with the patience of eternity. In a sense, the drift into darkness was not disappearance but return. The comet was going home, to the silence that had shaped it. Between the stars, conditions are nearly perfect for preservation. It would not erode or decay. It would continue unchanged for millions, perhaps billions of years. It would cross regions of gas so sparse they could not wear away a grain of dust. The energy that once defined its brightness was stored now in memory alone, spread across minds and servers and written into the slow language of scientific literature. The researchers who had followed it sometimes spoke of this image, a small, frozen object gliding through space without destination. For them, it had become a metaphor for continuity. The work of science, too, drifts outward from its origins. Each observation, each paper, each archived dataset travels forward, carried by others who may never know the faces of those who began it. Knowledge, like the comet, moves on, unhurried and indestructible. Somewhere far ahead of its present position, the comet would one day enter another system. Perhaps a distant star's gravity would bend its path once more, drawing it briefly into warmth before sending it out again. Perhaps it would collide with a planet, delivering the carbon compounds it carried into an unfamiliar atmosphere. Or perhaps it would wander forever, never again approaching a sun. No one could say. The uncertainty was part of the beauty. The universe keeps its futures unwritten, offering only the motion that leads toward them. On Earth, the telescopes kept scanning, turning through the night, their domes whispering against the wind. In their data streams, new points of light appeared and disappeared, asteroids, comets, satellites, but none yet bore the unmistakable signature of another interstellar visitor. Still, the watchers knew that somewhere in the unmeasured dark, others were on their way. The galaxy is always moving, always sending. It is only a matter of time before the next faint signal crosses the sky. And so, the drift of 3I Atlas continued, silent, unseen, perfect. Its departure marked not an end, but a reminder that existence does not depend on being witnessed. Even in darkness, motion endures. Even when forgotten, the universe continues to write its stories in trajectories and spectra, waiting for the patient to listen. If one could see it now, far from any light, the comet would appear almost still, a shard of ancient ice surrounded by eternity. No tail, no glow, no trace of its brief encounter with the sun. Yet within that stillness lies the essence of everything that moves, persistence without need, journey without destination. It drifts, and in that drifting, the universe remains alive. Long after the light of 3I Atlas had faded from every telescope, its influence remained woven through the quiet fabric of human thought. Its path through the solar system had lasted only months, yet the lessons it left behind would outlive every observer who had watched it. The legacy of motion, that patient reminder that everything moves, changes, and connects, became the comet's true inheritance. For scientists, the object had expanded more than knowledge. It had expanded perspective. It had shown that our solar system is not a closed system but part of a continuous exchange of matter where fragments from distant stars pass through without notice. The boundaries we once imagined, between systems, between origins, were illusions of scale. Every world, every sun, every speck of dust participates in the same galactic rhythm. 3i Atlas had simply made that rhythm visible for a moment. The concept of cosmic motion began to appear in research papers and lectures, not as poetry but as framework. Scholars used it to describe how gravitational interactions weave together the architecture of the galaxy. Others borrowed it as metaphor, teaching that discovery itself is a form of motion, thought traveling across time. The comet's trajectory had become a symbol not only of physical movement but of the movement of understanding. In universities, students studying astronomy often encountered 3i Atlas early in their courses. Professors used it to explain the mathematics of hyperbolic orbits, but also to illustrate the philosophy of science. Knowledge, one instructor would say, is not a collection of facts but a trajectory, a path through uncertainty toward deeper clarity. Many of those students had been children when the comet passed, and to them, it was history already. Yet the data they analyzed were direct traces of light that had touched a body from another star. Even across years, connection persisted. The legacy extended beyond academia. Artists painted the imagined journey of the traveler, depicting a frozen shape drifting through starlight. Musicians composed quiet, meditative works inspired by its passage, using slow, repeating tones to mirror its endless motion. Writers described it as a metaphor for solitude and endurance, a presence that asks for nothing yet gives perspective simply by existing. Each expression was an echo, another way of listening to what the comet had left unsaid. In the scientific community, the spirit of collaboration it inspired continued to grow. The networks built to track it evolved into permanent frameworks for global observation. Automated alerts now connected observatories in real time, ensuring that no faint visitor would ever go unnoticed again. Every new discovery carried a trace of Atlas's legacy, an invisible signature of improved cooperation and readiness. The memory of that shared effort had become part of how astronomy itself functioned. For those who had stood beneath the domes in those long nights, the legacy was more personal. They remembered not just the data, but the rhythm of observation, the soft whir of motors, the slow turning of the dome, the moment when a new image appeared on the monitor. The work had taught them that attention is its own reward. Even when the subject moves beyond sight, the act of watching transforms the watcher. Many who had taken part described a lasting calm in their lives afterward, as though something in the silence of the sky had recalibrated their sense of time. There is a quiet continuity in that. The comet moved through the solar system once and would never return, yet the motion it set in place on Earth would continue indefinitely, in instruments, in ideas, in awareness. The legacy of motion was not about a specific object but about what it revealed. That stillness, in truth, does not exist. Everything, from the smallest particle to the largest star, is part of a single choreography without beginning or end. Far away now, 3i Atlas continued along its invisible path, a silent ambassador of that truth. It did not know it had been seen. It did not need to. The light it reflected had already done its work. It had crossed space, entered lenses, struck sensors, and become thought. That transformation, from movement to meaning, was its true orbit, one that would never decay. And so the legacy of motion endured, carried not by the comet but by the minds it awakened. On clear nights, when astronomers raised their eyes to the sky, they no longer looked only for new discoveries. They listened for continuity, the hum of existence flowing endlessly outward, connecting stars, comets, and people in one boundless migration of light. In the end, the story of 3i Atlas was not about a single comet, nor even about astronomy. It was about perspective, the slow widening of awareness that comes from looking outward with patience. The visitor had arrived without warning, passed in silence, and disappeared beyond reach. Yet in doing so, it had drawn the human gaze further than it had ever gone. Its path had become a mirror of our own, a reminder that life, too, is a journey through motion and impermanence. By the time a full year had passed since its discovery, the comet had vanished from every instrument capable of detecting it. No telescope, no radar, no sensor could trace its light anymore. The universe had reclaimed its traveler, but its influence remained, carried in the minds of those who had studied it, written in the archives that held its faint reflections. The data would endure for centuries, long after the last person who had seen it was gone. In that endurance lay something quietly eternal, not immortality, but continuation. Astronomers often speak of horizons, both literal and metaphorical. There are horizons of vision, of knowledge, of time. Each discovery pushes those boundaries outward, even if only by the smallest fraction. 3i Atlas had expanded one such boundary, revealing that the galaxy itself is a continuous fabric of exchange. No place is truly isolated. The dust that built our world once drifted between stars. The atoms that form our bodies were forged in the heat of suns that long ago went dark. The comet was a reminder of that truth. That connection is the universe's most fundamental law. On Mauna Loa, the Atlas telescopes continued their nightly vigil. They turned quietly beneath the stars, scanning for new points of light. The operators had long since moved on to other projects, yet sometimes, in the stillness before dawn, one of them would open the archive and look again at the images from that distant year. Grainy though they were, they carried the same quiet power. Each frame was a moment in which the universe had looked back. The mountain itself seemed part of the continuity, its rock formed from fire, its summit rising above the clouds like an island in the sky. The people who worked there came and went, but the rhythm of observation never stopped. Every night, light older than civilization touched their mirrors, whispering of distances that defy imagination. The story of 3i Atlas was just one note in that endless music, but it had tuned the instrument. When new students arrived to train at the observatory, their mentors sometimes told the story of the interstellar comet that came and went, not as a legend, but as instruction. It taught us how to listen, they would say. It reminded us that discovery begins not with searching, but with noticing. The students would smile, unsure at first what that meant. But in time, standing under the dark sky with the sound of the wind around the dome, they would understand. In every science, there are moments that redefine what is possible. For astronomy, those moments often begin with something faint, a small point of light that turns out to be much more. 3i Atlas was one of those points. It expanded the horizon of the possible and, in doing so, revealed the horizon itself as infinite. There will always be another object crossing the dark, another chance to look, another fragment of the universe reminding us of its scale and grace. And somewhere out there, the traveler continues its unending path, beyond the reach of light or language. It carries within it the frozen dust of another sun, drifting now among fields of unseen matter, its motion smooth, unhurried, absolute. Perhaps one day it will pass near another star and, for a brief moment, glow again. A spark of reflection, another world's opportunity to learn. Here on Earth, its message remains simple and clear. Everything moves, everything connects, everything continues. The journey of one small comet became a reflection of all motion. The planets orbiting their suns, the stars circling the galaxy itself flowing through space. Nothing stands still, not even time. And so the story ends as it began, in stillness that is not still, in silence that speaks, in darkness that shines with the memory of light. The visitor has gone, but its lesson remains, that to look outward is also to look within, and that between those directions lies the endless horizon. We from Sleepy Stories wish you a good night.